Okay, welcome back. Welcome back. Okay, we continue from the last Monday. I hope you can hear me very well. Uh, saya harap you boleh dengar saya lah. Okay. So ini this is the IV curve that I explained last Monday. So this is the IV curve where this is the curve for the power lah. Okay. This part we call it as the MPP. Okay, MPP value. Okay, this is the MPP value. Where the value for that is IMP and VMP, which is the VMP less than VOC and the IMP is less than the ISC. So this is the basic fundamental characteristic of the PV module or PV cell. Okay. From there, there's the term we call that as fill factor. Okay. What is the fill factor? So the fill factor is like the ratio of the PMP to the total scale of the voltage, the highest voltage and the highest current of that certain module. So maksudnya, whatever it is, ni confirm lah, ini akan kurang daripada satu, must be lesser than 1, which is logic. Okay, this logic. So whatever it cannot be 1 because the IP, like I told you, must, in most cases is less than IC, and the VMP is less than the DOC. So this is what fill factor. So the fill factor means that the ratio of the range of the maximum power to the highest value, highest range. So usually this kind of value, this kind of factor comes in the journal. Journal that relates to the solar cell fabrication. Okay, in the study of fabrication of solar cells, usually the fill factor is coming out. Okay, that's where how they compare device or macam mana dia compare lah. So from here they say typical value, it's not the highest value, but typical value for fill factor is around 0.6 and 0.7. It doesn't mean that 0.6 is worse or 0.7 is better, just the typical value for the fill factor range. Okay. In other words, so conversion efficiency. Okay. In other words, we call that as conversion efficiency. So this is the efficiency. Okay. What is the basic equation of the efficiency? I think you all know already. Di mana nak nampak? Oh, okay. P out over P in. Okay. P out over P in. Mean output power over with the input power. This is normal. I think in the RF study also, the wireless transmission also, they're looking for the output over the input. So the highest the output compared to the input means that device is very efficient. It means that high efficiency. Ideally, we cannot make 100%. 1.0 is extremely impossible. But close to the 95%, 90%, that is considered as very high efficient. Okay, itu yang people are looking for that. Okay, what is the other equation? Okay, this is the P out and P in. We don't know the value of P in for that. So the same equation for that is the G multiplied with A. Okay, G multiplied with A is the value of the P in. So the P in, how to get the P in? G solar irradiance on that part. Okay. Okay. G is we call that as the instantaneous solar irradiance at that specific time. For example, if we want to calculate the efficiency, you want to look the efficiency of the solar module, the output power of the solar module, the output characteristic. So we have the irradiance. The area sometimes fluctuative if you do the measurement under the sunlight. Okay, so that specific solar irradiance too. That's why it is fluctuative. They fluctuative. Okay, so that's one. A is not the current. Not current, not ampere lah. A is the area, active area of the cell. Okay, active area of the cell means that in datasheet, okay, datasheet, PV module datasheet. The PV datasheet, usually they write the dimension. Okay, the dimension of the solar module. For example, kenapa macam ni? Okay. Tak nampak dia punya point. Okay, ni kan. Contoh lah, this is 0.9 meters and this is 1.7 meters. So the active area is considered as this lah. 1.7 multiplied 0.9 meters square meter. In unit square meters. Okay, maksudnya ni adalah unit dia adalah meter square. Why the irradiance? You know already, watt over square meter. Okay. Then the P out is the PMP, which is the IMP multiplied VMP, which is this is equivalent to so this is also equivalent to PMP lah. Okay, PMP. So IMP multiplied VMP, you get the PMP. Usually you just take the PMP value enough lah. Okay, no need to look for the IMP and the VMP. So this is the conversion efficiency. So the efficiency of the solar module. Okay. From the size, okay, the ratio of the conversion efficiency is the ratio of the power to the size of the solar module, like that. Okay. The power with the ratio of the power, the PMP to the size. The size of the module lah. So kalau sepatutnya if the size is lesser, if the power is out, mean if the power is more, why the area that means very efficient. Boleh dengar saya ke? Aku cakap seorang. Boleh dengar saya ke? Boleh
Doktor, boleh.
Boleh clear
Clear.
For example, if we have this kind of solar module, let's say we have this kind of solar cell. Nampak tak? Ini sebenarnya bukan nak belagak ni. Contoh saya ada pump size of solar module. Ni bukan pen drawing pen tu. Okay. Let's say kita ada size ni. So if this size we can produce 100 watt of output, means extremely very efficient lah. Maybe in the future with this only size we get the 100 watt. Okay, tapi yang saya ada kat belakang ni dia besar, size dia masih besar, mungkin sekitar 0.5 meter multiply with 0.9 meter. With that size we get only 100 watt. Maybe in the future small size can produce 100 watt. It means that very efficient solar module lah. So people are looking for that. Okay, compact size but highest output. So that's the one of the ideal our ideal desire lah. Itu semua orang nak macam tu lah.
Our output of a module depends on the number of cells. Tadi saya sebut tadi, kalau satu solar module tu kan, satu solar module tu biasanya dia adalah combination of several seriously connected solar cells. Okay, it is called as the solar module. Okay, solar module. So the bigger the size of the solar module means the more the numbers of the solar cells are attached on that. And then after that it is assembled lah. So dia assemble mengikut size lah, size watt berapa banyak nak. So that's why kalau lebih besar modul tu, lebih banyak lah solar cells yang kecil-kecil tu yang rectangle yang kecil-kecil tu, bukanlah kecil sangat pun, pelubuk sambung sambungan lah. Then type of cells macam saya cakap tadi semalam tu ni yang whether monocrystalline ataupun poly ataupun multicrystalline lah. Okay. So next is total surface of the cell. Okay. Depends on the total surface area of the cells. And then the most important thing is these two. So dua ni, saya tak nampak ni point ni. Okay, yang ni. So the power of module changes depending on, there's two factors that affect to the output of the solar module. What is that? It is amount of solar radiation or solar irradiance. I mean the instantaneous irradiance will totally affect the output of the solar module. Okay. Another thing is the temperature lah. Temperature of the module. Ini kita panggil juga sebagai T-cell. Cell temperature or the module temperature. So these two factors. Okay, these two factors. Solar irradiance is the strength from the sunlight. The sunlight strength. Macam kekuatan sun, okay, light intensity or the sunlight. Okay, the sunlight, the strength of the sunlight. Okay. Betapa terik dan panasnya matahari itu akan memberi efek to the output of the solar module. Another thing is the temperature. The higher the temperature is, the lesser the performance is. Bukan maksudnya temperature lagi tinggi tu lagi bagus, tak. Sebenarnya temperature lagi tinggi tu dia akan affect the characteristic of the silicon itself. That's why dia akan degrades the output performance of that solar module. Okay, itu yang benda yang umum. Okay, effect of solar irradiance. Okay, tak nampak lagi situ punya. So current output, okay, current output of a PV module is highly dependent on irradiance. Okay, current to affected by the irradiance, significantly affected by the irradiance. So while the voltage output does not change dramatically. Okay, tapi voltage is not that significantly changes due to the change of the solar irradiance. So you still can dapat irradiance, I mean the higher voltage, but doesn't mean you get the higher current, because that higher current totally depends on the irradiance. So if you look at this figure yang saya cedok dia dari mana, saya tak tahu modul apa bila dia measure, kita tak tahu. But that's not important. The important thing is what I want to show you. This is the trend where the irradiance, kalau S atau G, G is getting bigger. Okay, kau tengok bawah kan, 200, 400 watt, 600, 800 and 1000 watt. Means that significantly significantly changes. For example, 200 watt maybe 1.2, and then when it goes to the 1000 watt, it goes to 1.19, 5.19 contoh, saya petik lah 5.19 tu. So maksudnya iridium berubah, iridium bertambah, the output current also significantly bertambah secara drastiknya. Okay, secara drastiknya. Daripada 1.2 dia melompat menjadi 5. So which is very significant. Berapa persen tu? Maybe 400%, kan? 400% or more than that. Okay, but if you look at the voltage itself, okay, the voltage itself, okay lah, this one close to 20 something. This one still 20 something. I think around 20 to 22. Only that 2 volts of difference. While the irradiance changed from 0 to 1000 watt over square meter, and the current also changed from the 0, okay, from the 0 until 5, which is the maybe 400%, like that. Okay, so they significantly change. So that's why it's very critical to not to have any obstacles or any shadow that block your surface of the solar module. That's why we do the solar pathfinder. I mean the solar pathfinder study. We do the solar site analysis. We do we measure the shadow of that specific place for the whole year. every month we calculate, we estimate the percentage of shadow that might affect our module for the whole year. Sebab tu penting benda tu. Kita tak nak ada any degradation ataupun any shadow that comes or block shadowing your module. It's very critical because once you are shadowed, your module are shadowed by the trees or the buildings, so it will totally degrades the output current that you may generated. Even though if you measure the voltage, there's not really difference. The value is not that different. I told you from here, from this graph, you can see around 20 to 22 only. But the current is totally changed already. That's why we need a very stable, sun or the solar source. Okay. So once the current is totally significantly changed, power significantly increased with the increase of the solar. So power, at last, the power also significantly increased with the increase of the solar irradiance. Maksudnya, when solar irradiance getting higher, current getting higher. G getting bigger, current getting bigger, and finally the power also getting bigger lah. So that this is the thing that we want. Okay, right. Next factor is the temperature. Okay, the effect of the temperature. Okay, the output of the cell or module depends on its temperature during operation. The module temperature gets elevated when exposed to the sun. Elevated tu maksudnya rise lah. Okay, rise. Increase pun boleh kot. Okay. When exposed to the sun, logic lah. Plus, it's made by the silicon or made by the aluminum. So if you touch the panel itself under the sunlight, you feel the hotter than your body, the hotter than the sun. The hotter than the sun that you reach. Macam mana? Daripada sunlight yang you dapat direct pada badan awak tu. Kalau pegang dekat permukaan yang tadi lah, dia lebih panas lah. That's why the calculation of cell temperature tu ada related dengan ambient temperature punya calculation lah. It's not same. Cell temperatures are higher than the ambient temperature because there's calculation there. Okay. So current marginally increases with an increase in module temperature. You can refer to this graph. Same. I don't know what type of graph, what type of solar module they use. I don't care because the important thing is to see the difference between the temperature, right? The difference between the current or the voltage to the temperature. I mean temperature dependent characteristic. So you see here 25 degree, 50 degree, and 75. From here, at the top looks same, no difference, but it drops earlier when the temperature is higher and drop later when the temperature is lower. Means that current marginally increase with an increase in module temperature. Dia ada naik sikit lah ni, tapi saya nampak macam sama je lah. That's why I said slightly increase. So you can say that it's slightly increase lah. It's slightly increase with an increase in module temperature. However, voltage, this is the critical one, voltage significantly decreases with an increase in module temperature. So if you look here, yang ni lebih broad. Okay, the change what we call it, slightly broader than before, than the solar irradiance one. But solar irradiance not different, not that different, the voltage. But here, the change in voltage is quite major. You can say major lah. Mungkin sini saya agak mungkin 20 dan 18, which is 2 volts for this different 35 degrees difference, 2 volt berbeza. So nampaklah dia ada significant tu. The change is significant for the higher temperature. So that's very critical. That's why there's a cooling system. Sometimes there's some study they do the cooling system on the module. Even sometimes not worth because you need the water flowing, something like that. It's very complicated. Okay, very complicated. But the voltage, I mean the temperature should be maintained. It should be maintained in the lowest, not lowest temperature, not the very highest in temperature, in order to make sure that the PV modules works well, operates well during the day. So kalau terlalu panas tu dia mengganggu efficiency of the output voltage tadi. Voltage akan drop, dia degrades lah. Walaupun kita rasa panas, mungkin nak mampus kan, Tapi bila tengok modul, kenapa tak maksimum? Kenapa tak maksimum? Because dia sepatutnya anti-temperature lah. Temperature tu yang menyebabkan dia degrades. That's why power significantly decrease lah. Okay, power significantly decrease with an increase in module temperature. In other words, T getting higher, voltage drops, and finally the power also drop. Once the power drop means the efficiency is significantly decrease. Okay, that's why kita kalau boleh nak kena maintain suhu tu. Kalau ada cooling system, that's better, but that one is very difficult lah. Very difficult to have that kind of setting in the solar farm, for example. It's very difficult. Okay. Boleh ke? Is it okay? Boleh?
Okay, sir.
Okay, sir. Tak boleh. Memang next week ni kena start face to face ni, lemau ni. Okay. Right. So, two factors that disturb the output performance of the PV modules. One is the solar irradiance. Solar irradiance is positive impact lah. And another one is the temperature. Temperature is negative impact. The higher the temperature it is, the worse the performance of the module is. Okay. So temperature adalah musuh kepada PV modul. Macam tu lebih kurang. But the irradiance is the friend, is the ally. Okay, like I told before, just now, cell operating temperature. Okay, the empirical formula for calculating the T cell. So this is what we call the T cell or the T module lah. Boleh lah T module. Tapi saya tak tulis pun sama ni T module. Kita panggil cell temperature lah. It's the same thing. Okay, it's the same. Because all the cells, all the solar cells attached on that certain module is all the same type. So kita panggil juga cell temperature. Tidak ada dosanya. So cell operating temperature. Where does it come from? I mean the equations. It's come from the T ambient plus. So there's a plus there. It's impossible to get the same value with the T cell and the T ambient. If the T cell is lowest, means that T ambient must be very lowest. If the ambient temperature is minus, so that means that our module closer to the efficient one, closer to the ideal one. Sebab nanti suhu tu lagi rendah lah. Okay, NOCT. What is the NOCT? Nominal operating cell temperature. Don't be panic. It's all in the data sheet. Okay. After this, we're going to look at the data sheet. Dan dekat situ kita akan main dengan NOCT. Where should we take the value of NOCT? It's coming 100% ni from the data sheet. Tahu data sheet? PV. Nanti kita akan belajar modul apa benda kan. Kita akan ambil satu modul data sheet dan kita cuba extract. Okay, ada NOCT, ada berapa nilai dia dan sebagainya lah. T ambient is given lah. It is given in the question. Okay. And then NOCT minus 20 and then over 800 watt of skin meter. Don't ask me why over 800, why not 700, why not 600, why not 500. It's basically derived from some books. Okay. So T cell, so the cell temperature is coming from this equation. So just accept lah. Jangan query lah kan. Kita tak dia lah, ambil di value ni dengan yakin, tanpa ragu-ragu. So G, next, multiply with G, where G is the instantaneous irradiance, instantaneous solar irradiance at that ambient temperature. Means that this kind of cell temperature is actually fluctuating, depending on that instantaneous solar irradiance and that instantaneous ambient temperature. So maksudnya benda ni tak fix lah. Dia akan berubah lah setiap hari. Daripada pagi sampai petang pun akan berubah. Contoh tengah hari lebih panas contohnya. So the cell, logically the T cell also becomes bigger lah. Kan? Logik lah kan. Sebab kenapa? T ambient ni tambah. T ambient tambah. Lepas tu irradiant pun tengah hari lebih panas. Lebih terik. Dia akan getting bigger lah. So the T cell temperature will rise. Okay, will rise during the midday lah. Okay, in the case where the NOCT is not available, use T cell equal T ambient plus 35 degree. Pula merah banyak sikit. In case the value NOCT cannot be found in the data sheet because there's some modules data sheet, in data sheet they don't write the NOCT value. Is totally annoying lah sikit sebab kita nak cari tak dapat nak calculate. Mungkin the performance dia very good, but when we try to estimate, it's not difficult. Even though we have the typical value of NOCT, for example 47 typical value, for example, of the NOCT, but still on that specific model we must refer directly from the manufacturer. So if the manufacturer doesn't write anything in the data sheet, so we cannot assume some value. I'm afraid it's disgracing that company. That's why we don't use any value. You can put typical value, but it's not sinful if you just put T ambient plus 25 degrees C only, if the NOCT is not given. Same case, if the G is not given, also you can use T ambient plus 25 degrees C. Boleh. Maksudnya kalau NOCT dan G tak bagi, boleh terus langsam lah T ambient plus 25 degrees C. Means that if the ambient temperature is 30, for example, so 30 plus 25, so let's say 30 and 30 plus 25, we get the 55 degrees C is the cell temperature on that specific question in that specific condition. Okay? Boleh? Boleh ke? Boleh lagi kan? Boleh tak boleh pun kena bolehkan juga. Okay. Saya tak nampak awak. Semua
Okay,
jadi
doktor, okay.
awak tidur ke, tengok Netflix ke, tak tahu kan. Okay. PV module specification. Sorry, tak nampak lagi. Okay, PV module specification. So a data sheet provide technical information required to design and install PV array. So we call that PV module specification or specification data sheet. Okay. Useful for consumer to compare different module as it provide basic information about efficiency, rated power and physical size. So dalam PV module punya specification data sheet tu dia ada dah tulis IMP kan, ada tulis ISC, VMP, VOC, lepas tu ada NOCT, okay. Lepas tu mungkin nanti ada tolerance dan sebagainya. So it's everything should be attached on that same data sheet lah. Okay. The data physical output rating of PV size module are given as specific condition. These conditions are called as standard test condition. Keluar lagi perkataan ni, standard test condition. Kita panggil sebagai standard test condition. Okay. What is the standard test condition? Kasi tulis lah. STC. Okay. STC. Standard test condition ataupun STC. Considers value of irradiance. Okay. 3 parameter yang penting here, irradiance, cell module temperature and A mass, AM. Okay. Irradiance should be 1000. Mana ni? Irradiance should be 1000. Cell temperature should be 25. And AM, A mass is 1.5. When these 3 conditions are fulfilled, it can be called as the standard test condition. The the specification of the solar module in that data sheet provided by certain manufacturer, for example, that STC condition means it fulfill all these 3 conditions. Okay. Irradiance 1000, temperature 25 degrees C, cell temperature bukan not ambient temperature but cell temperature, and the A mass of 1.5 AM. Okay. So this standard test conditions to refer to this. Okay, refer to this. Masih bisa lagi ke? Boleh lagi?
Boleh.
Boleh saya.
Untuk sikit lah kan. Biasalah tu. Okay. Configuration. PV cell and module. I explained already before, but this one I think more clear lah. A single solar cell normally fabricated by the manufacturer. We have that kind of company. For example, in Melaka, Sun Power. Sun Power is the US company. Okay, they manufacture, start from the raw material of the silicon. They use the multi-crystalline silicon, original material tu. They fabricate, they manufacture, they process until they get this kind of beautiful solar cell. slice in the same size of the slice cell kan. So it is called as solar cell. Even though to produce this kind of a piece of solar cell also, there needs several different process of the cutting, the deposit, something like that, or the process is, I think, more than 7 or 10 or 15 processes until they get a beautiful solar cell lah. Then I'm telling you about the case of the sun power. I'm not promoting, but because we just visit one semester before the COVID semester, so we have visited to the sun power Malaysia in Melaka. Ala Gajah, tak ingat. Ala Gajah ke Air Keruh? Ala Gajah kot. Ala Gajah. So that sun power, so they manufacture, they fabricate everything, the solar cell, and the solar cells will be exported to the US back. I think US, not China. US to be assembled so that it will become the modules. Yang case tu contohnya dekat Malaysia, dia keluarkan solar cells. So all the solar cells are packed very well in the container, they put in the box, and they export using the container, a big container carrier, the carrier through the to the sea, to the ocean freight. And then when reach at the US, so they start to assemble. So assemble means one solar cell, more than one solar cell will be assembled. There's process lah. Lepas tu dia letak encapsulant, lepas tu dia letak frame of the aluminium frame. Depends on the size that one lah. For example, 100 watt, 200, 300, 400, 500. So that I told you, the module, the power of the module, the output of the module depends on the number of cells in there, and what type of cells are used. So sambungan tu lagi besar watt dia tu, lagi banyak lah solar cell dia, lagi besar size dia. So modules. So that modules again, I think they will export to other place lah. So kat kita pun ada, memang buat dekat Melaka tu lah sun power tu. So it becomes the module. Yang you panggil solar panel tu kan. Sebenarnya bahasa yang betul, the correct term is the solar module. Okay, solar module. Okay. Then several modules that are connected in series, we call that as a string. PV string. Okay, we call that as PV string. Several modules connected in series. Okay, series. When it comes to series means what will be different. For example, we have the the value of the current, the value of the voltage. So when we connect in series, what will change and what will not change? Apa yang akan berubah bila connect in series? Abdul Fakih.
Saya.
Apa yang berubah if we connect the solar modules, several solar modules in series? What will change? Power ke, current ke, voltage ke, apa yang akan berubah? Dan apa yang tak berubah?
Power mungkin berubah.
Power mungkin berubah, betul. Lagi?
Tak sure.
Series. Sama series. Modul tu sambung series. Ini kena tahu ni macam mana nak sambung solar kat atas bumbung ni. Okay, power you kata okey dah. Ada dua lagi parameter. Current ataupun voltage. What happen to current, what happen to voltage?
Current sama ke sir?
Jangan tanya saya tak jawab. Okey, jawab.
Current sama, voltage berubah. Good.
Current sama, voltage berubah. Kenapa voltage berubah?
Tak tahu lah.
Main teka. Betul-betul main teka ni. Saya tanya orang lain lah. Lim Sen Ye.
Yes, sir.
Lim Sen Ye. What will happen when we connect the solar modules in series? Your friend said the voltage will change, but the current remains. Why?
Voltage remain and current change.
Mungkin sebab dia sambung ke Siri kot sir.
Kamu sendiri ikut mati dia berubah ke? Macam tu kan?
Gitu.
Okey lah. Tak apalah. Sing-sing.
Okay, so
Okay, solar cells like a battery lah. Battery. Same case with the battery lah. Kalau you sambung battery kan. Sambung battery. Buruk. So, sambung battery ni maksudnya voltage akan bertambah lah. Betul? Sebab sambung series, so the voltage will be multiplied. Okay, ada kawan awak tulis Ohm's law kan. Saya tulis sebab Ohm's law tu V sama IR kan. Tak apalah. Tapi konsep dia kita sambung series. So bila sambung series tu dia voltage yang sama lah. Voltage sama untuk setiap modul tu sambung. Dia sambung macam battery, then the total up of the voltage getting bigger lah. So voltage akan bertambah. While the currents remains the same. Voltage different because each component is series form. Maksudnya apa? Voltage different. Kalau if we have the same modules, same size, same pattern, same brand, it should be same lah. I mean for each voltage tu, you sambung 4 and then dia akan dapat total up lah. So, total up voltage lah. You akan dapat total sum out of the voltage. But the current, if the module is the same, then dia akan dapat the same current lah for one string. Maksudnya, untuk case string, biasa modul ni, jangan buat silap If you want to connect several cells, several modules in series, it must be in the same brand. Okay? Same brand, same size. Penting betul. Kenapa? If the current is different. Okay, for example, macam mana cakap contoh kan, yang ni kan. Okay, empat ni semua 100 watt. Contohnya semua 100 watt, semua 100 watt, semua 100 watt, semua 100 watt. Voltage pun mungkin 20, tapi kalau current dia ada 4, ada 3, ada 4, ada 3. Okay. Sebenarnya dari segi discipline to connect the solar modules ni, it's not correct. Sepatutnya you kena connect yang sama rated je. Okay, sama rated je. Dalam series tu terutamanya, sama rated. You akan dapat voltage yang multiply, tu betul. Kalau 4 ni maksudnya kalau satu ni V, so total V total dia you akan dapat 4V lah. Betul. V total akan dapat 4V sebab for same rated of the modules is connected in series, then you are going to get the output of the, so that PV string is the total up of all voltage. What about the current? The current is critical. Current total ni sebenarnya because it's connected in series. Kita tahu kan, connected in series, current tak berubah. Current sama. Okay, current sama. So, maksudnya kalau 5, kalau semua brand sama, contoh 5 amps, so semua akan dapat 5 amps. Dia takkan multiply. Tapi kalau ada modulnya 5, 4, dia akan follow yang the lowest one. Okay, the lowest one. So, even though you ada satu modul yang majority modul, for example, you get 5 amps. Tiba-tiba you salah beli kan, ataupun guna apa yang ada, dia pun letaklah satu modul 20 volt juga, dia punya VMP, tapi mungkin watt dia rendah sikit, you just letak, contoh dia punya amps dia 2.5, dia akan ikut 2.5 tu. Dia tak keluar yang 5 amps. Sebab yang modul yang terganggu tu dia tak cukup power kan, maksudnya memang tak cukup current dia banyak tu je, so dia akan keluar yang tu je lah. So the whole string tu akan drop current dia. Sebab tu masa nak install tu sangat kritikal. Jangan campur-campur modul. Kalau nak tukar satu set. Satu set yang sama. Nanti complicated. You akan mencela benda tu. Kenapa tak keluar kan? So display dia, it must be in the same brand, same size. Same rated power, same rated voltage, same rated VMP, same rated IMP. Then you install your modules in string. Okay? Then you are going to get the expected voltage Kenapa voltage nak tinggi ni? Biasanya kita guna inverter lah untuk jadikan input kepada inverter. Grid inverter. Okay. Kat solar farm contohnya, recently they are looking for the highest voltage, not the higher current. Sebab channel tu dia ada highest voltage tapi still dapat P power. Dia ada IPP function so that the over voltage tu the extra voltage from there will be converted to the extra current, something like that. Extra power from there. Okay. Sebab dia akan IPPT, dia akan target for the highest. Okay. So there will be a multiplication of the current after that. So ingat, modul kena sama sama rated, sama IMP dia, sama VMP. Kalau contohnya brand Shahiman 150 watt, so you kena beli kat Shahiman 150 watt banyak-banyak. Banyak-banyak dari saji kan, so saya untuk lebih macam tu. Beli banyak benih-benih yang sama. Okay, benih biasa. Tapi if you use recently they have the Huawei inverter tapi that one specific for the grid connected application. For that Huawei inverter very special because the input voltage for each string can be different, not same. Sebelum ni kita assume, sebelum ni the way kita calculate, the way kita estimate guna the conventional grid inverter, kita nak satu string satu biji. Contohnya satu biji voltage ni, let's say lah kita letak 25 volt satu ni kan. Mana ni? Tak nampak. Okay. 25 volt, 25 volt, 25 volt, 25 volt. So you are going to get 100 volt kan. Usually before the recent attack inverter comes in, kita guna yang channel punya inverter, grid inverter ataupun multi-string inverter for example. So kita akan 100 volt string yang pertama, string kedua pun sama juga 100 volt, string ketiga pun 100 volt, string keempat pun 100 volt, semua sama. Tapi recently yang Huawei tu, dia punya channel tu dia boleh varies ganas gila. Maksudnya kalau rendah 4 biji, satu string 4 biji, satu string 5 biji pun tak ada masalah. Itu untuk yang brand Huawei yang baru lah. Tapi tak apa, itu cerita-cerita kat grid connected. Okay. Boleh string tu string multiplication of voltage but the same flowing current. Okay. Make sure you are using the same brand, same size, same rated VMP and IMP before you do the installation. Okay. Okay, next. That string. Then again, we have the next is the array. Array, what is that? What we call array. Strings connected in parallel, it is called PV array. Okay. Kalau you nampak satu baris ni, macam satu baris ni kan. Ni kan satu baris. Satu baris kan. So kita panggil string lah. String pertama, string 2, string 3, string 4. Tapi kalau you nampak benda tu lebih pada satu line, kita panggil array lah. Okay, panggil array. Basically, generally strings in parallel. Array is the string in parallel. Maksudnya yang ni series. Okay, ni boleh panggil sebagai PV string 1. Ini string 1. Ini string 2. Ini string 3. Ini string 4. That means that we get 4 strings connected in parallel. Kenapa macam mana tahu parallel? Ni dia parallel kan sama semua. Okay, ini parallel ni. Parallel kan. Positif semua sama positif satu kabel. Dia tap satu, negatif semua dia tap satu point. Then same case like the battery battery yang you sambung-sambung tu. So ini kita panggil PV array. Yang ini saya cakap tadi berdasarkan physicality. Visibility yang kita nampak dari mata kasar. Mata kasar maksudnya nampak daripada atas kan. Kau boleh nampak lah kalau dia berbaris tu kita panggil PV array. Kita tak panggil PV string. Kalau lebih daripada satu baris, kita tak panggil PV string lah. Kita panggil PV array. Tapi kalau ada panjang satu tu, okey ada satu string. Ada PV string atas, contoh lah gunakan term yang betul. Okay, PV array tu still doesn't mean that all are connected in parallel. Sebenarnya. Yang ini secara physical. Secara zahir ini kalau kita tengok, when you see there's several lines of modules are installed on the roof. Line pertama, line kedua, line ketiga, kita panggil terus PV array. Ada PV array atas tu, bukan PV string, PV array. Tapi the real one, whether it's connected in series or parallel, how many series and parallel sebenarnya, you kena check on the back of the connection. Maksudnya kena nak terbumbung ataupun tanya owner, berapa parallel, berapa series ke semua series. Dia mungkin jadi juga semua series tapi dia susun secara parallel disebabkan space of the roof.
So kira dia punya connection tu kalau macam ular ke dia tu series lah.
Ulang balik. Ular.
Dia punya connection tu kalau macam ular, so dia kira series lah.
Yang tengah-tengah ni kan?
Tengah-tengah macam ular kan sir?
Ya,
Dia
ular.
punya
Ya,
connection.
so, kalau ada 4 ular yang diikat sekali, tu panggil array lah. Tapi mereka cakap walaupun you nampak macam array, faham tak maksud saya? Kalau atas bumbung you nampak ada macam kiri ni, macam kanan ni. Contohnya, macam kanan ni, tengok daripada bawah, bumbung orang kan, macam ada, dia ni mungkin PV array dah. Ni kita panggil PV array, betul. Tapi sama ada semuanya parallel ke, semuanya series ke, tak tahu lagi. You kena tengok connection wire belakang tu. Kadang-kadang dia susun macam tu kan, dia susun nampak macam ni. Padahal semua series pun possible juga. Dia sambung macam ni kan, faham tak maksud saya? Kalau kita susun dua ni, yang ni kan, susun contoh dua macam ni kan, ada kemungkinan yang ni yang disambung kat sini. Kan? Yang ni sambung sini, yang ni positif, yang ni negatif. Possible. Memang possible. Tapi dari segi zahir kita tengok daripada bawah tu, kita boleh sebut PV array je lah. Tapi connection dia macam mana? You kena naik atas bumbung, kena tengok wire dia sambung macam mana. Then baru tahu berapa series, berapa parallel. Ataupun paling senang kau tanya owner je lah kan. Kita minta diagram kan, schematic diagram. Selesai. Tapi kita boleh agak lah. Jadi daripada bawah tu kita dah boleh tak agak-agak. Kau-kau macam pro sangat lah. Nampak macam boleh. Okay. PV array apa punya? 4 darab 2 ke? Berapa parallel sebagainya lah. Ada soalan?
Ada Ustaz, ada.
Tidak. Kita tengok next apa jadi. Kita tengok slide ni. Okay ni dah masuk temperature coefficient. Boleh aku sentuh sikit. Okay. Temperature coefficient. Okay, kita dah selesai. We have finished the factors that affect to the output performance of the PV module, which is the saya ulang balik, G and the T. Okay, G and the T. Solar irradiance and temperature. These two factors affect the output of the PV module. Okay. From there, okay, the temperature tadi, okay, temperature ni, dia susulan dari chronology from that temperature factor. There's come another words we call it as temperature coefficients. Yang ni we are going to go detail what is the meaning of that temperature coefficient. Apa kaitannya dengan output? Kenapa voltage tu turun? Kenapa current tu naik contohnya? Kenapa current akan naik bila temperature turun? Bila temperature naik, current naik sikit. Bila temperature naik juga, voltage turun. Kenapa? So this is the calculation that relates to that things. Okay? So this is the logic where it comes that kind of the term lah. Okay, engineer manufacturers provide the values of their module temperature coefficient in their commercial specification datasheet. Okay. PV modules. Okay, PV modules punya datasheet, datasheet tu. So dalam datasheet tu ada macam value saya cakap ada IMP, ada VMP, ada ISC, ada VOC, and also they have the value of temperature coefficients. Okay, that temperature coefficients. So that value also are should be given by the manufacturer in their datasheet. If that value is not given, I think that you should choose other modules lah from other company lah. Means that maybe the company is not proper. But basically, they all attach all that information in that datasheet lah. Okay. So these coefficient values are extremely important to determine corrected output values. Okay. Ada term baru ini. Corrected output values of current, voltage and power when the module is operated at various climate conditions. I mentioned just now, in that datasheet, they give you the STC value. Okay, the STC value means that standard test condition that fulfill irradiance 1000 watt over square meter, stand temperature 25 degrees C, and the AM 1.5. Okay, but in order to calculate the corrected output values ni sama konsep dia macam instantaneous power atau instantaneous short circuit, instantaneous current, instantaneous voltage. Kita nak kira instantaneous ni yang tengah operate while operating tu. Maksudnya operating condition. ataupun kita panggil real operating condition of the modules. Kita panggil juga sebagai corrected output values tadi tu. So kita perlukan temperature coefficient. Faham? Maksudnya kita nak calculate instantaneous punya value sekarang berapa. Dekat situ kita kena tahulah berapa. Tu kita main T-cell tadi, cell temperature ada tadi kan. Ada G yang berbeza dan ada ambient temperature yang berbeza. So temperature coefficient ini juga importance variables yang kita nak letak dalam calculation so that kita boleh estimate instantaneous voltage tu berapa sekarang contohnya. Sebab dia bukan STC kan. Suhu sekarang dia ada 35. So suhu 35 ambient tu maksudnya kalau set temperature dia akan tinggi lagi kan. So maksudnya kita nak kira corrected, kita panggil sebagai corrected output values. Tak apa, jadi kita ada calculation, jangan risau. Ini baru term yang untuk understanding. So typically temperature coefficient of current is a tiny positive. Okay. Ini dia punya simbol. Ini gamma current. Gamma current ni, temperature coefficient of current is a tiny positive number. Tiny positive number. Nanti akan tengok dekat datasheet lah. Memang nilai positif yang kecil lah. Okay. Itu untuk current. Number which indicates that the output current increases marginally corresponding to the increase of temperature. Maksudnya current increase marginally. Tadi kita cerita kan temperature tu current akan marginally increase but the voltage will significantly decrease. That's why temperature coefficient for current you akan nampak nilai dia slight positif. Ada tiny positif. Nilai dia positif, tak ada nilai negatif. Nilai positif. Okay. For the case of voltage, its temperature coefficient denoted by the gamma voltage is relatively much bigger with minus value. So much bigger with minus value. Tadi current adalah tiny positif, tapi voltage sebab dia degrades kan, voltage tu turun significantly due to the increase of the temperature. That's why the value for temperature coefficient for the voltage are bigger with minus value. Indicates that the output voltage decrease significantly corresponding to the increase of temperature. So this is the meaning. Okay, right. Okay. Equation yang seterusnya. Okay, equation yang seterusnya. We call that as the temperature coefficient factor. Okay, temperature coefficient factor ni dalam unit F10x. Okay, F10. Where the X, okay, mana ni tak nampak, mana dia, okay, X ni adalah, okay, X ni kan, X is the temperature coefficient of parameter X for the module, okay, ini adalah temperature coefficient okay, gamma X ni juga, salah, okay, gamma X tu adalah temperature coefficient of parameter X for the module. Apa parameter tu? It can become X could be ISC boleh, VOC boleh, IMP boleh, VMP boleh, PMP boleh. Maksudnya fleksibel, semua boleh. ISC, current, voltage, power semua boleh. Itu adalah X tadi tu. Tapi the temperature coefficient gamma X. Unit dia adalah percentage over degree C. Unit dia adalah percentage over degree C. Sekejap. Okay. Alright. So this is the basic equation for the temperature coefficient factor. Okay, temperature coefficient factor. Okay. Corrected output. Okay, sekarang baru masuk dekat corrected output. Tadi saya cakap temperature coefficient factor ni is the default equation for the temperature coefficient factor in the unit of percentage over degree C. Okay, it applies to all. Okay, it applies to all. It applies to all calculation lah. Untuk power, current and voltage. Okay. And then next is the corrected output. Okay, the corrected output mana tadi? Ada tak keluar. Okay. So for the case of yang ini, okay, for the case of the, we call that X. Okay, X corrected ataupun kita panggil sebagai temperature coefficient gamma X in the unit of percentage over degree C. Tak apa, ini you hadam dulu hadam dulu. Saya nak tunjuk equation dulu. Nanti jangan risau, kita akan buat practice. Kita akan buat exercise, okay? Tidak susah nak faham ni. Kena buat exercise. Okay. So X tu, saya kata kan, X ni boleh jadi apa saja. X corrected could be corrected value of the ISC, VOC, IMP, VMP or PMP. Maksudnya dia akan jadi, dia boleh jadi ISC corrected, boleh jadi VOC corrected, boleh jadi PMP corrected. Okay. So X. So flexible lah. Mana-mana pun boleh. So X STC multiply with F temp. Just like that. So X STC. Sebut aku payah. Okay. Yan. Mana ni? Allah. Gerak-gerak. X STC ni can be IFC value, VOC value, IMP value, VMP atau PMP value, the STC value for these values daripada datasheet tadi. Maksudnya boleh mana-mana lah. Dia boleh mana-mana, tak kisah. Kalau contoh yang tadi, let's say lah saya decide dengan ISC corrected. Okay, ISC corrected. Jadi begini lah, saja je. ISC STC. Ini maksudnya ISC STC. If VOC corrected, so VOC STC. Boleh ke? Boleh ke ni? Boleh ke? Celotan ni macam payah sikit lah. Boleh ke? Boleh ikut lagi ke? Hello?
Boleh saya.
Bolehkan je Nanti saya ulang lagi. Okay, nanti saya ulang. Minggu lepas saya ulang lagi. Okay. Tapi kita betul-betul lah. Boleh. So, ini ni. Equation dia ni lah. So, ini equation dia. 1 plus, okay, 1 plus alpha x multiply with T cell minus T STC. T cell macam mana nak kira? Macam mana nak kira T cell? Apa equation untuk T cell? Tanya sikit. Tadi buat tunjuk. Equation untuk T cell apa Ingat tak? Tak ingat. T ambient
plus NOCT minus 20 divide 800 kali dengan G.
Allah teruknya. Kenapa dia sini lah? Sikit hati lah. G. Tu dia tinggal G. Okay, nanti bagi G. TSTC berapa TSTC? How much value of the TSTC? TSTC pula. TSTC, How much is the value? Cepat. TSTC berapa nilainya? Tak ada orang jawab. Oh my god. Semua dah berkerut nampaknya. Semua dah memegang kepala masing-masing, berkerut. Berapa? TSST berapa value? Teka je lah, please.
25 degree C.
Betul. 25 degree C. Allah, kenapa dia begini? 25 degree C is the value for the TSTC. Okay, value for the TSTC is 25 degree C. Kejap. Ni Jawa nak begini sekejap. Okay. Saya tunjuk dulu nanti kita akan buat latihan. So, kita akan buat latihan dengan hati yang tenang. Okay. So ini bila kes apa tau? Ini bila nilai ni adalah percentage over degree. Percentage over degree. The temperature coefficient of the value is the percentage over degree. And then this one pula benda yang sama, kira untuk corrected juga, tapi kes dia untuk kita panggil absolute value. Okay, ini kalau ni tak kisahlah. Contoh ni dia tak kisahlah, dia boleh jadi gamma ISC ke, gamma VOC ke, gamma PMP ke, ikutlah, mana-mana pun tak kisah. Kalau dia keluar value millivolt untuk voltage, milliamps untuk current, dan milliwatt untuk power, dia lain sikit. Apa bezanya? Okay, pinjam sini. XSTC, okay, saya beri contoh ISC corrected sama dengan, asal dah sambung tension macam ni, benci tau. Okay, data ISC darab T-cell tolak TSTC. Jahat ada keluar. Jahat. Okay, buguk gila tulisan, ya Allah, malunya aku. Okay, apa beza dengan yang tadi? Tadi apa beza dia? Aku tak sempat tengok pun sekilas. Okay, tadi tu IC core, saya pendek lah. Ya Allah, dia macam ni, jahat tu lah. Kenapa dia macam ni? Kenapa? Darab 1 tambah. Okay, baru masuk dia punya gamma. STC kan ni ISC, STC. ISC T-cell tolak TSTC. Jahat betul lah. Okay. Beza dia kat sini. Okay, mana dia tak nampak. Okay, sini beza dia. Kat sini beza dia sini. Dia ada perbezaan kat sini. Ini kalau absolute value dia tambah saja, solid tambah, settle. Kalau percentage, kalau nilai dia percentage macam ni, dia ada darab 1 tambah. Darab tu ada, dia ada darab kat situ. Okey, dia ada darab. Itulah yang membezakannya. Okey, saya tahu dah benda ni. Masa bila nak guna benda ni? Masa bila pula? Tak apa, nanti tu kalau ada contoh nanti saya tunjuk. Okey. Saya nak bagi you ada idea terus benda ni. Equation ni mana datang. So maksudnya hari ni kita belajar 3 equation lah. T-cell. T-cell tadi sama dengan ni T ambient campur NOCT minus 20 over 800 multiplied with G. Equation pertama. Equation kedua, temperature correction factor. Okay, tadi. Tapi saya rasa tak payah tahu pun temperature correction, tak apa tak? Sebab kat sini dah masuk dah. Yang ni kan. Yang ni dia dah embed sekali dalam ni. Tapi tak payahlah, kiranya you ingat yang ni je. Okay, X corrected yang pertama, kalau nilai dia percentage, dia STC multiply 1 plus. Ni untuk percentage. Dia ada multiply dan 1 plus. Tapi untuk absolute value, dia tak ada satu tadi tak ada hilang. Dan tak ada darab, dia tambah. Okay, ni tak apa, masa kita buat latihan nanti akan nampak lebih jelas lah kot. Dia akan nampak lebih jelas. Okay, jom kita shopping sekejap. Ni shopping. So ini adalah contoh, this is an example of the solar module brand SAPC 170. Short kot. So ni 170 watt. Ni sebenarnya old school lah, saya tak tunjuk latest ni. Malah nak cari. Saya pakai lama je, recycle. So ini contohnya dia ada 13.1 module coefficient efficiency. Okay, ni contoh. Tapi yang ni bukanlah yang kita nak tengok. Okay. Yang ni saya cakap tadi kan ada yang kira kan. Kalau you ingat tadi saya cakap kita ada pengiraan apa nama tu? Conversion efficiency. Betul tak? Conversion efficiency yang pengiraan itu IMP darab VMP G multiply with A. So A ni lah adalah length multiply with width of the module. Okay, mana dapat sini? Ni dia. So yang ni, ini adalah width dia. Okay, ini contohnya 0.826 meter. Lepas tu ini adalah length 1.575 meter. Okay. So ini adalah area. Okay. So ini adalah area yang dimaksudkan oleh equation ni. Ini. Macam mana nak cari area daripada soalan modul punya size dimension. Okay. Dimension. Okay. Okay. Right. Then, okay, dari sini ni contoh datasheet contoh datasheet yang ada. So ini dia bagi tahu lah, ni dia bagi tahu IP tu pelik dia tak panggil IP, sebenarnya orang panggil IMP. Kenapa dia pakai IP? Tak apa, okay. So ini patutnya wording yang betul lah. Wording yang betul adalah VMP lah. Tak tahu dia tak sekolah apa. Ini PMP, ini IMP. So ini value dia. Ni kan, the ethical data apply to the standard test condition. Ini kena ada tengok wording dia lah. STC. Kenapa saya cakap kena tengok wording ni? Kadang-kadang dia orang ada bagi dua nilai lah. Satu SC, satu lagi dia ada nilai NOCT. NOCT maksudnya dia ada IMP, VMP, ISC, VOC untuk NOCT satu, untuk STC satu. Dia kadang ada confusing sikit gitu. Okay. So maksudnya ada dua nilai IMP dan VMP tadi. Ni contoh nilai lah PMP, VMP, IMP, VOC dengan ISC. Okay. Lepas tu nanti ada power tolerance, tapi tak apa, awal lagi kita nak belajar. Sebab itu kat chapter grid related, tapi tak apa, saya tunjuk tak. Ni ada rated power may vary. Ni kita panggil sebagai power tolerance. Power tolerance ataupun tolerance ataupun manufacturing tolerance. Okay. So ini rated power may only varies minus 5 plus 10. Ni ada benda lah. Maksudnya dia ada tolerance. Tolerance maksudnya contoh yang ini 170 watt kan. 170 watt tu maksudnya ketika maksimum tu, maksimum case dia boleh pergi sampai 170 10%. 187 watt sampai tolak 17 ke. Tolak 17 tolak berapa? Tolak 17 tolak 8.5. Mungkin satu je. 45 161.5 kot. Maksud dia ni at the peak hour, peak power tu, kat peak power tu dia akan varies lah. Varies sekitar, dia tak constant. Standard lah, benda ada tolerance kan. So ia bergantung pada the way they manufacture ataupun stability of the module itself lah. Tapi untuk case ni dia declare minus 5% sampai 10%, plus 10%. So maksudnya value yang patutnya 170 watt tu dia varies. 161.5 sampai 187 watt. So dia akan varies fluctuate macam tu lah. Macam tu lah, paling maksimum pun dia turun sampai 161.5. Ini untuk peak hour, betul-betul peak time tu. Peak power kan. Okay. Itu satu. So ini tadi boleh cari kan. Length. Tadi ini pasti ada length and width untuk kira A. Lepas tu apa lagi? Apa lagi sini? Okay. Ni dia panggil temperature coefficient. Ni temperature power. Yang tadi kalau ingatlah saya kata gamma PMP tadi tu. Ni ada. Yang ni open circuit voltage. Open circuit voltage punya VOC, gamma VOC. Ini maximum power voltage. Ni VMP lah. Bukan ni maksudnya dia bagi VMP punya nilai. ISC dia tak bagi. Itu saya cakap ada yang tak bagi lah. Patutnya dia bagi ISC. Tapi dia tak bagi. Okay, yang ni nampak ni. Ini watt over C, degree C, yang ni vote over degree C, ni vote over degree C. Ingat tadi kan kalau saya cakap kalau dia keluar absolute value, bila kita kira corrected tu kan, you kena kira contoh macam tu VOC STC sama dengan VOC STC. Silap ni corrected. Sorry ni corrected. Tambah. Okay, tambah. Terus letak nilai ni contohnya. Negatif 0.1728. Darab T-cell. T-cell kan, tolak STC. Itu maksud dia. Ni sebab dia bagi absolute value. Okay. Tak pernah saya bagi contoh je. Yang ni pun contohnya dia bagi tolerance juga kan. Ni pun ada tolerance juga. Plus minus 5%. Okay. Lepas tu ini ada dimension dia bagi. Lepas tu ni dia bagi apa ni? Dia bagi BMP, IMP, VOC, IC. So ni ada nilai dia lah. Lepas tu dia bagi temperature coefficient. Ni tulis dia macam ni pula. Ini voltage coefficient, temperature coefficient. So ini equation tadi. Tapi yang ni ingat dia ada percentage pula. Maximum power biasanya bagi percentage. Yang ni saya cakap tadi tu. Yang ni pula kita pakai contohnya kita pakai PMP corrected sama dengan PMP STC darab 1 plus. Okay, PMP punya coefficient T-cell tolak TSTC. Ni saya cakap contoh tadi. Ini bila dia keluar percentage. Jadi equation ni kena ada darab dengan tambah. Darab kata tambah. Okay. Then ni apa ni? Nominal operating cell temperature. Tadi tak bagi kan? So tadi tak bagi ingat Kalau tak bagi tadi ni kan. Tak benda ni sekarang untuk faham je. Nanti baru kita buat latihan. Yang ni kita nak kira T-cell. Clearly the value of the velocity is not given. So macam mana kita nak kira? Kita terus di ambient ambil ijtihad ni 25 degree C terus. Selesai. Untuk kes ni sebab velocity tak bagi. Tak bagi kat mana-mana pun tak bagi kan. Okey. Yang ini velocity diberi. Ni velocity dia bagi nilai 45. Jadi ini kena kira lah T-cell sama dengan T ambient campur velocity minus 20 over 800 multiply with G. Ini kena pakai. Yang ini kena masuk nilai 45. Yang ini kena masuk nilai yang diberi oleh soalan lah. Okey, ini contoh data sheet lah. Okey. Ini yang lain. So ini apa ni? Ini saya cakap tadi. Kita kena refer yang standard test condition. Akan tetapi there's some manufacturers they are given NOCT also. Ni NOCT punya condition pun dia bagi. Nampak ni dia ada PMP kan? PMP, VMP, IMP ni bagi tak? PMP, VMP, IMP, VOC, IC pun dia bagi juga. Kita jangan ambil NOCT ni. Yang nilai untuk VMP, PMP ni. Kita kena ambil yang STC. Tapi nilai TNOCT ni yang degree degree. Yang ni kena ambil ikut modul lah. Ni 45. Tadi 45 kan? Ini 45.4. So this is the value of NOCT roughly. Okay. Okay, ni contoh-contoh modul lah. Ini untuk yang ni. Kat empat dah. Okay, ini pun contoh. Ini contoh dia bagi temperature coefficient untuk IC. Yang ni dia bagi percentage. VOC pula dia bagi millivolt. Ni equation yang nombor 2 tadi. Ini equation pertama. Ni equation kedua. Ini temperature coefficient of power. Ni pakai equation pertama juga sebab percentage. Lepas tu ada velocity dan sebagainya lah. So ini contoh data sheet yang saya ada. Ini contoh Ini contoh velocity dia tinggi sikit 48. Tapi 40 something lah, 45 sampai 48 lah. Yang ni velocity dia 47. Plus minus abaikan, kita ambil dia depan je. Okay, ini question. Dah saya habis kat sini. Ini question. Nanti kita buat practice. Minggu depan kita buat practice. Exercise. Jangan risau. Saya akan patah balik. Itu. Any question? Our midterm test tu sepatutnya cover sampai chapter ni lah. Pengiraan corrected ni memang akan masuk. Yakin. Jamin akan masuk untuk midterm test lah. Saya cadang midterm test tu mungkin buat minggu ke-7 atau minggu ke-8. Saya rasa mungkin minggu ke-7 kot. Ataupun tengok kesayan lah. Minggu ke-8 pun boleh juga. Cumanya minggu ke-8 tu selepas midterm break. Dia tak shock sikit. Saya tak suka lepas midterm break, mungkin sebelum midterm break pun. Tengok macam mana. Tapi kalau kita buat test tu pun mungkin test contoh saya bagi contoh mungkin test kita, midterm test kita on week 7. Contoh mungkin test week 7. Week 7 Rabu, Wednesday waktu kelas 2 hingga 4. Ni high possibility. Sebab rasanya minggu depan sikit. Okay, minggu depan tu kita dah habis lah cover yang ni. So maksudnya dah cover, midterm test ni dah settle. Lepas tu kita akan masuk grid connected dan standalone tadi lah. Okay, any question? Cepat, habis dah, pukul 4 dah. Sorry lah, ini internet problem lah. Sakit hati betul. Any question?
No, doctor.
Tak ada sir.
Okay, kalau
No,
tak
sir,
ada,
no, sir.
Ya. Soalan ke? Tak ada
Tak ada sir.
Okay, kalau tak ada, thank you and see you next week. Sepatutnya akan ada group yang face to face lah. Isnin depan. Okay? Selamat.
Alright.
Jaga diri.
Baik.
Okay, for
Thank you,
those
sir.
who are going back for Deepavali, okay? Selamat bergembira. Okay?
Thank you.
Selamat bergembira. Okay. Duduk, jaga diri. Jaga
Ya,
diri.
sir.
Kopi.
Thank you, Doktor.
Okay, sama.
Thank you.
Thank you, sir.
Thank you, Doctor.
Thank you, sir.
Thank you,
Thank
sir.
you.
Thank you, sir.
Sama.
Thank you, Doctor.